Problem number 4. Show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. So it's hard to even say, how this is an optimizational problem, but largest area. Okay, what am I trying to maximize? The area. It's a rectangle. I want the largest area. So, look for keywords that explain what's going on. So I have a rectangle. Draw a picture. It's a good idea to draw a picture for every problem. Rectangle has 2 dimensions, an x and a y. All right. I want the largest area, so my equation for what I'm trying to maximize, my step 1, area equals x times y. Okay, what's an equation that I have that relates them? Well, they said is a square with a perimeter of 8, an 8-meter perimeter. So the perimeter is 8. That means that 2x plus 2y equals 8. So 2y equals 8 minus 2x, y equals 4 minus x. All right, so that's my step 2. Step 3, I'm going to sub this into here, sub this into here. So then my area is equal to x times 4 minus x, which I can simplify as 4x minus x squared. Now to solve this problem, I don't even need calculus actually. Since my area expression is quadratic, I can say, oh, that's a parabola. I just find the vertex. It's negative b over 2a, and but what's a, what's b? I have to remember that formula, blah, blah. Look, it's actually easier to do with calculus. Step 4 is we find the derivative. Look how easy to find the derivative. It's 4 minus 2x. Step 5, I have to set it equal to 0. How easy is that? 4 minus 2x equals 0. And, in less time than it would take me to look up the vertex formula, I already know that x equals 2. All right, and I want to prove that that's a maximum. Now, I could appeal to the graph and say, okay, this graph is a parabola facing down. Therefore, it has a maximum. It does not have a minimum because the leading coefficient is negative. All right, but it's pretty easy to do second derivative test. So just because we won't always be able to do that easily, let's do second derivative test. A double prime is equal to negative 2. A double prime of 2 is negative 2, which is less than 0. Therefore, A has a max at x equals 2 by second derivative test. Okay, step 7, what other variables do we need? Well, our job is to show that it's a square. So if it's a square, I need to show that x and y are equal. So the easiest way to do that is that since x equals 2, y, which is equal to 4 minus x, is, right, 4 minus x, that's what y is. Did I say that somewhere? Yeah, y is 4 minus x, is also equal to 2. All right, since x equals y, the rectangle is a square, QED, booyah. And number 4 is done in barely 3 minutes.